Hello. Today we're going to be looking at lesson 7.7, which is factoring special products. So we've already been working with factoring and you've actually already done special products. So today is kind of almost an accumulation of two lessons. So why don't we go ahead here and try number 1 and 2. So in number 1, if you remember, again, it's from lesson 7.3, you're going to FOIL this out. Okay, so we're going to do first, outer, inner, last. So if we do first, x times x. If we do outer, x times -5. If we do inner, 5 times x. And then if we do last, 5 times a -5. And what you're going to notice is your middle two terms will actually cancel each other out. So we're left with x squared minus 25. And that would be our final answer. Now what's going to happen in today's lesson is they're actually going to go in reverse. They're going to give you this will be given, and then you are supposed to give them the binomials, okay? So remember, this is multiplying, and then when you have to create the parentheses, that's called factoring. So in the special products, there's two of them. This was the first special product, and this is called the difference of two squares. So why don't you pause it here now, and why don't you try number 2 if you kind of know what I did on the first one. Just remember, you cannot distribute the square. So you might want to rewrite this with both of your parentheses, because if you distribute the square, you're going to miss something. So go ahead and pause it here. All right, hopefully you tried it. And again, we're just foiling. So we're going to do first, we're going to do outer, inner, and last. Now be careful, we're multiplying. So 3 times 3 is 9. Now, notice your middle terms don't cancel like they did over here, but do you see how they're exactly the same? So that's going to be x squared plus 6x plus 9. So in this special product, which we called square trinomials, okay, in this one, we notice that the middles double and not cancel. So sometimes people will multiply these two numbers together, so they'll go 3 times x, and then whatever that number is, so 3 times x, then they'll double it, okay? So that's just kind of a way to like check to make sure that the pattern works. Okay, that's just kind of a little shortcut. But those are the two pieces for our lesson today. And so today's lesson really is the reverse of 7.3. So almost, if you probably look back at your 7.3 paper between the notes and the homework, you probably will see these answers. But we're just going to be going backwards. So they're going to give you this to start, and they're going to expect you to be able to write that down. So again, we're going in reverse. So if you turn to page 11, at the very top, you'll see the two kind of shortcut patterns. I don't think you really have to do much with these, but they just want you to pay attention, like the difference of two squares. This is the one where our middles drop. And the biggest thing you have to pay attention to, I kind of like this example better than I like the algebra one, is you have to have both perfect. So the x squared and the 9 are perfect, and it has to be a subtraction. And if it's that way, then you know your middles are going to cancel. So do you see how inside the parentheses you have 1 plus and you have 1 minus? Because that's the only way to get our middles to cancel, is to have a positive and a negative. If we were to have both positives, if we were to have x plus 3 and x plus 3, our middles would not cancel. So we would have our outer and our inner, and they wouldn't cancel. If we were to have both subtractions, they still wouldn't cancel. We'd have a -3 and a -3, and they still won't cancel. The only way to get them to cancel is to have them be of different signs. And it doesn't matter which one comes first. If you want to have the plus first and then the minus, or vice versa, it doesn't matter. But this way, when we do our outer, we get a negative, and when we do our inner, we get a positive. So that means they will cancel, okay? So that's the first shortcut. And so let's just practice a few of those. So if we look at the first row, you're going to notice that these are binomials. So see how they don't have a middle term. Do you notice they're also perfect squares and they have a subtraction sign? Every single one of them perfect squares with a subtraction sign. So if this is the case, we know we're going to have two binomials. We know our signs are going to alternate, and it doesn't matter which one you put first and second. And then you're going to take the square root of the first, so the square root of s squared, and the square root of 49. And if you check your outers and your inners, so if you do the outer and you do the inner, you're going to see that they cancel each other out. So we know we've done it right. So why don't you quick try 4? You probably don't even need to pause it. Just hurry up and write it down. All right, you should have t minus 9 and t plus 9. Do you see how I did the subtraction first? It doesn't matter which one you do first as long as you have the t and the 9 and then the alternating signs. If you look at number 5, notice you have a number in front of your square term, but that's okay because it's still a perfect square. So we're still going to take the square root, so 2g times 2g. We're still going to take the square root of 25, so we have 5 and 5. And then we're going to alternate our signs. And again, if you check your outers and your inners, you're going to get a negative 10g, and then when you do your inner, you'll get a positive 10g. That's how we know they're going to cancel, okay? If we look at number 6, you'll notice 6 is kind of backwards. You really don't want to switch this because you need the negative. You need the subtraction to be with the x squared. So don't switch it. Just keep it the way it is. And you're going to take the square root of 16, the square root of x squared, and then you're going to alternate your signs. And then you're done. Now this only works if you have a binomial. So if you have two terms. As soon as you go to a trinomial, this is not going to work because now we have a middle term. But that's this other pattern that we did where we have this quantity squared. So you can either look at what they call the algebraic abbreviation, or you can look at the like the numerical version here. And so notice if we have x plus 3 quantity squared, we're basically distributing. So we're doing x squared, 3 squared, but we can't forget about the middle term. And so you'll see it right here. If you multiply them together, so if you do 3 times x, then you just have to double it. So then you would just times it by 2, and that gives you the 6, okay? The other thing I want you to pay attention to is whenever you see the word factor, they basically want you to create parentheses. That's what they want you to do. So if you look at number 7, they want us to do the parentheses. Now, if you don't recognize this is a shortcut, we can go back to a previous lesson, like 7.4 and 7.5, where we learned how to factor. So we ask ourselves what multiplies to get x squared, so it would have to be x times x. We know our symbols are the same, and when we look back, they're both plus signs, so we know that. And then we would have to think of the combinations of 64. And there's quite a few combinations of 64. But one of the most common combinations of 64 is 8 times 8. And so if we try 8 times 8, when we do our outers and our inners, you're going to notice that's a positive 8 and another positive 8, and there's our 16 that we needed. So in this rule, our parentheses are exactly the same. Exactly everything from the variable to the number to the symbol. And so we are just going to write this as x plus 8 quantity squared. So that is this rule up here where it's called a perfect square trinomial, okay? But the big thing here is this is a trinomial. And you have perfects in the first and the last. So let me try another one with you, and then I'll have you try a couple. So if you notice, the first and the last are both perfect. Now, if you don't recognize 169, then you can grab your calculator and you can take the square root of the number, and you'll notice that it does come out to be perfect. So we know this is going to be the square root, And notice our symbols are going to be the same. And so when we look back, it's a subtraction. They're both subtractions. But because it's two of the same parentheses, then we just do quantity squared. But if you want a quick check, if you want to do the shortcut, if you multiply these together, r times negative 13, so you get negative 13r, and then if you double that, do you get your middle term? And since we do, then we know we've done this correctly, okay? So why don't you pause it here and try 9, 10, and 11 on your own? All right, I hope you paused it and gave these a try. Let's try number 9. So we know this is p plus, and if you're not sure about the square root of 196, just go ahead and type it in. We kind of want you guys to learn the first 10 perfect squares, but beyond 10, I think you could probably just use your calculator. So this is the square root of 196 is 14, and so if we square that, now let's just check. If we multiply these together, we get 14p, and if we double it, because we know the outers and the inners will be the same, do we get 28? And we do, so we know we're done. It's always good to quick check those middles just to make sure. All right, number 10. We get a minus, because there's a subtraction, and then the square root of 81. That one you should know because it's less than 10. And then we do quantity squared. And again, if we multiply these together, we get a negative 9a. And if we double that, do we get negative 18? And so we know we've done it correct. Again, we're just following a pattern. So it's all about patterns here. All right, number 11, square root of 100 is 10. And then we have 10x. The square root of 1 is 1. I know it's kind of a silly one because 1 times 1 is 1. But the square root of 1 is 1. So we still have a perfect square. And then this tells us our signs are the same. And so we look back and they're both subtractions. So if we check again, if we multiply those together, we get a negative 10x. And if we double that, notice how we get a negative 20, okay? So I really, really want you guys to be careful here because what happens if they would have given you a problem that was x squared, how about minus 10x plus 16? This is kind of a trick because when you look at this, it's perfect and it's perfect. But if I go x minus 4 quantity squared, when I multiply these together, I get a negative 4x. And then when I double this, I do not get the correct middle term. So this is a really mean one because it kind of tricks you because you've got the first and the last are perfect. But there's another combination that multiplies to get 16 besides 4 and 4. And so in this particular case, you would actually want to use x minus 2 and x minus 8. Because if you notice, when I do my outers, I get a negative 8x. My inner would be a negative 2. There's my negative 10. And when I do my last, a negative times a negative is a positive, and 2 times 8 is 16. So I always recommend checking that middle number to make sure it works, because I've seen enough problems where they may try to trick you. But in this case, it does work, so we know we're done, but just really watch that. Now, the last part of the lesson today is solving. When you hear the word solve, you are trying to figure out where does this thing cross the axis. So if I was to look roughly at a graph, now I could type this into my calculator. I could definitely go to the y equals and I could type this in. The problem is it's probably not going to show on my graph. Now we haven't done a lot of graphing yet, but let me just show you. You're not going to probably see anything because these numbers are so large. So unless you really want to sit here and play around with the zoom feature, this is going to be extremely difficult to do in the graphing calculator. But what this question is really asking you when you see the word solve is where is it crossing the x-axis? Is it crossing here? Is it crossing way over here? Like, where is it crossing? So you need to solve these. Now, there's a difference between a binomial and a trinomial, okay? There's two ways I can show you how to do a binomial, but there's only one way for a trinomial. So let me show you the first way with the binomial. This question right here looks no different than your number 3. The only thing that's different is they put an equals 0 on the tail end. So let me just show you, if this was the problem I was working on, and this had an equals 0, what I basically just have to do is solve each of these. S plus 7 equals 0, and S minus 7 equals 0. And so if I finish this off, I get S to be negative 7 and S to be positive 7. If I were to be graphing this one, it's basically telling me that it's crossing at negative 7 and positive 7. So somehow this graph is crossing at those two locations. So you have to do the same thing on number 12. You need to factor this. So you're going to need to go x times x. And if you don't know the square root of 144, it's 12. So you're going to have a plus 12 and a minus 12. And then you equal 0. And then now you're going to set each one of your parentheses equal to 0. And then you're going to solve them. You might be able to do this one in your head because the numbers aren't too big, but when you get to a little larger one, you might need to write it down, okay? So if we move the 12 over, we get negative 12. And then if we move the 12 over on the other side, we get positive 12. So that's why we couldn't see it on our graph, because it's too big for my window screen. My window screen only goes to positive 10 and negative 10. So I would have to use my zoom feature and try to figure that out. But that's really not what we want to do. We want to just kind of work it out and see, because if it comes out to be decimals, it's even harder in the calculator. Now the other way, I told you there was two ways I can do a binomial. I can only do a trinomial one, but a binomial I can do multiple. A binomial, I could have just moved the 144 to the other side. See how I moved it over? Now that my square term is alone, I could just take the square root and I get x to be 12, but you have to remember from Algebra A that whenever you take the square root, you have to do plus or minus. So do you see how I got the negative 12 and I also got a positive 12? So notice there's two ways to solve this, okay? So I'm going to skip the trinomial for just a second, and I want you to look at 16. Do you see how 16, the 100 is already on the other side? So if I was doing 16, I think I would just do this method. So I would probably just from where it's sitting, go ahead and take the square root of each side. The square root of 100 is 10, and then I just have to do plus or minus. Now, if you want, I could move the 100 over. So I could say 0 equals m squared minus 100. And then I could go ahead and factor this. I'm just trying to kind of write small so I don't run into the other problem. M plus 10 and m minus 10. But do you see how I would get a negative 10 and I would get a positive 10? But do you see how much faster this method is? So binomials, again, I feel like have a quicker, faster way of solving. Now, number 17 has a little twist to it. So you might have to kind of think about number 17. But if you notice, number 17 has an x behind it. So this is a little different because you see how the 100 did not have a variable. In this particular case, we need to do the greatest common factor. So if we pull out the greatest common factor, we pull out a 4x. These are both divisible by 4x. So if I divide a 4x out, I'm left with x minus 5 is equal to 0. Now I still have factored, but this was a tricky binomial because it had another variable and it wasn't perfect. The 20 is not perfect. Even if I keep 20 alone, it's not perfect. If I divide it by 4, it's not perfect. So this is kind of what I would call an old problem, hidden to try to trick you. What you want to do now is just set each one of these equal to 0 And you still get two answers. So you still get x to be 0 and you get x to be 5. It's just not what I would call symmetrical. So instead of crossing like number 16 crosses at 10 and 10, so you have 10 and you have negative 10, so it's even, the same distance on each side. This one crosses at 0 and it crosses at 5. So it's just not symmetrical over the y-axis. It still has what I would call like a division line at the halfway point, probably at 2.5. It still is halfway, but it's not evenly split on the y-axis. So your goal today, the goal is to be able to factor to get to solving. So the whole method of factoring is trying to get you to the solving portion. So if we look at 13, if I just cover this up, it's really no different than number 10. It's just now we threw an equals on it. Okay, so let's try 13. This is a trinomial, and notice we have a perfect and a perfect. So let's see if we can try our technique or our trick here. We're going to square root the first, square root the last. We know our symbols are going to be plus signs. Now let's just quick check our outers and our inners. So we're going to multiply these together and we're going to double it. And do we get 14 back? So we know we've done it right. They didn't trick us. Now all we have to do is solve this. Because what you're really telling me is it's c plus 7 and it's c plus 7, which equals 0. So both parentheses are the same. That means there's only one solution instead of two. So my answer is -7. Over here, we had two solutions. So we had that it crossed at +12 and -12. So it crossed twice. Now, what you're telling me on this one is that -7, it's only crossing once. And I wouldn't even know if I would use the word cross. I think I would use the word touches. So what it does is it comes down and it touches this location and then it goes back up. But you're only asking me where does it touch? And so that's the answer I'm providing. So why don't you pause it here and try 14 and 15, both of them. Try these two before we turn. Okay, hopefully you tried it. Number 14 was a trick. I hope you noticed it right off the beginning. Is 15 perfect? The answer is no. So if it is not perfect, then you just have to factor it like we've done the last couple lessons. So you're going to do x times x. This is telling you my signs are going to alternate. 15 is only made up of 1 and 15 and 5 times 3. But which combination is going to get you to a 2? So we're going to use the 5 and the 3. We know the signs have to alternate. And since I want this to be a +2, I need this as a +5 and a -3. By using that combination, if I check my outer and my inner, that gives me a +2, which is what I want. I always check my outers and my inners. And you might be getting to the point where you can do them in your head. All right, now we're going to let x plus 5 equals 0, and then x minus 3 equals 0. Basically what they're asking you is what does x have to be to get this to be a 0? So if x is -5 and if x is +3. So those are the two locations of it crossing. Now if we go to 15, do you notice how this is perfect? I think I would still be cautious because they just tricked you once, but let's give it a try. We'll take the square root of d, the square root of 4. We know our signs of subtraction. If we multiply them together, that would be a -2. And if we double it, do we get this term back? And we do, so we know we're done. Now we just have to solve it. Now remember, this just means there's only one solution. kind of like the one we did up here. So when you move that 2 over, that means it crosses at 2, okay? And you're going to be dealing more with the graphs in a future chapter, but if you know it's touching, I guess I should say, at 2, we're going to talk in another chapter about, is it going up or is it going down? Because really, it could go either way and still touch, okay? So that's kind of what we're going to be looking at. In our class, we're not going to get any that potentially would go sideways like this. And if we were together, I would ask you, why can they not go that way? And you should be answering vertical line test. It's not a function. It doesn't pass the vertical line test. So they don't give us any of those ones, okay? Now, if you went to a really high-level math class, you might see those, but we're not going to see those in our class. All right, we got 4 questions to go. Why don't you pause the video here and try that top row? All right, I hope you paused it. If you didn't, maybe watch one and then pause, and then try one and then pause, because remember, you're going to have to be able to do these on your own, so it's really important that you try them. On number 18, really on this whole row, you potentially need to move everything to one side. So you need to move this 9 over. So I'm going to move the 9, and I'm setting it to 0. And then I'm noticing that this is perfect and this is perfect. I just don't want them to trick me, but I'm going to try my best to hope that they didn't. I'm going to take the square root of 16, and I'm going to take the square root of 9. And I know my symbols are both plus. And then I'm going to quick multiply these together. And so I get a 12. When I multiply 4 times 3, that's 12y. If I double that, do I get 24? And the answer is yes. Now, on the next step, you have to be really careful because this one's harder to guess. So if we solve this, we would move the 3 over, and then we would divide by 4. So we get y equals negative 3/4. So once again, that's telling you where it crosses, okay? All right, the next one, if we were together, I would be asking you, what do you think I should do? Because there's 2 ways you can solve this. You could move the 121 over just like we did in the last problem. So you could subtract 121 like that. And then you could factor it because both of these are perfect numbers. But remember, because it's a binomial, you have to alternate your signs so that the middles will drop. See, over here, we want the middle term, so see how we keep them the same. Over here, we want them to drop. So the square root of 36 and the square root of 121. Now, if you realize these parentheses are exactly the same, so when you set them equal to 0, one is going to become negative because when you move the 11 over, it becomes negative. And the other one is going to be positive because when you move the 11 over, it turns positive. But you'll see that both of them are 11 divided by 6. You just have a positive and you have a negative. And so you can either leave your answer as a fraction, or if you guys want to divide it out and leave it as a decimal, it's like 1.83 repeating plus or minus. That would be fine too. Now let me show you the other way. Very similar to what we did on the front side. Because the 121 does not have a variable, we could divide off the 36. We just have to be really careful because when we divide by this, it comes out to be a nasty number. So if you try to round this, if you write down 3.361 or something, you could get some potential error. So I'm going to try to take the square root without any error or out any rounding. So I'm going to go second square root, and then I'm going to use the answer feature. Now this is not going to give me any rounding. And if I wanted, I could kick it back to a fraction as well. Okay, so again, you have 2 options. It's up to you which way you want to solve this. Let me just show you if I try to use some, if I use some rounding, so 3.361, notice how my answer is really very similar. It's just look at the tail end. So in our class, I don't think that's going to make a difference, but if you were in a career or something working with decimals, that might throw your problem off. So you want to be really, really cautious on your rounding. All right, the next one, this one, again, is going to be a trinomial because we have a square, a single, and a constant. So we have to move the number over. We don't really have a choice on this one. So we move the 49 over. We really only have the choice on the binomials where we have a square term and we don't have the single. This single c, the single variable, really throws an extra wrinkle in our problem. But we're going to try this because it looks like a perfect and a perfect. So we're going to hope that they're not trying to trick us here. And we're going to go for our shortcut. I always go for the shortcut first. And I check and see. And if I'm wrong, then I guess I got to go back. But I always try that first. So let's quick, couldn't grab my paper here. Let's quick multiply them together. So 6c times 7 would be 42c. And if I double that, I would get, what, 84? And that's my middle term. So I know I've done it right. So it's like, whew, thank you, okay? And since they're the same, that means there's only going to be one solution. So I set it to 0. I'm going to move the 7 over, and then I'm going to divide by 6. So c equals negative 7 over 6. Or if we want to type it into our calculator, again, we get a decimal here, so that's up to you. Negative 1.16 repeating. Doesn't really matter which way you leave it, okay? That is the majority of the lesson. Now, number 21 is going to be a significantly long, harder question. So I'm going to try to go kind of fast here to get this done, but I just want you to know they're trying to give you some application. So in 21, they give us the dimensions of a rectangular prism. So we have, let's just say, length, width, like height. It doesn't really matter. We have 3 dimensions. And then they tell us the volume. Well, if this is rectangular, then all we have to do is multiply these 3 pieces together, and we're going to set it to the volume, okay? So I'm going to try to write small here. So we've got length times width times height equals volume. So, and it doesn't matter because the commutative property, which one you do first, second, and third, we just need all 3. And so there's my volume, or my 3 pieces set to my volume. I'm going to quick FOIL this out. So I have first, outer, inner, last. Let me just clean this up. That's x squared plus 3x plus 2. But I still have this 4 sitting there. Now I'm going to have to distribute this 4. So I'm going to go 4x squared, 4 times 3x, 4 times 2, and then I still have this piece. Now, in order to solve this, because it says what is the value of x, which essentially is saying solve, I need to move these 2 to the other side. So I'm going to subtract 24. I'm going to move over here. So 12x minus 24x would be a minus 12. And then I'm going to add 1 and add 1, so that would be a plus 9. Now I've gotten rid of everything on the right side, so this is going to equal 0. And now this problem doesn't look any different than number 20. So in this particular question, you had to do a lot of work to get it to this point. Once you get it here, now you need to factor. And because it's a trinomial, and because the first and the last are perfect, we're going to try our shortcut. So we're going to take the square root of 4x, the square root of 9. Then we know our symbols are both subtraction. We're going to test real quick. So we're going to do 2x times negative 3, which is a negative 6. And if we double that, we get a negative 12, which is correct. So I like to have that scrap paper kind of handy so that I can work those out. All right. Then if I set 2x minus 3 equal to 0, if I move the 3 over, and then if I divide by 2. So I get x to be either 3 halves, or I think some of you are pretty comfortable in saying 1.5. So that concludes 7-7. Remember, you had 2 shortcuts here, okay? And you gotta make sure that you're practicing so that you can really be good at those 2 when they're hidden with other problems. Because tomorrow, you're gonna be factoring all kinds of things. So you might see some of these pop back up. But that concludes 7-7.